Welcome back to another deep dive. Today, we're looking at just a breathtaking cosmic scene. We're exploring the Elephant's Trunk Nebula, and we're working from this incredible image you shared as our source material.
Yeah, it's fantastic. And it's much more than just, a pretty picture. It's like a live window into how stars are born.
Yeah.
Happening about, 2,400 light years away, so quite a distance.
It really is. And what gets me is the story behind this specific image. Our source mentioned it was taken by Luc Debec over 8 hours of exposure time.
That's right.
From his own backyard in Belgium. It's kind of amazing, isn't it? Backyard astronomy capturing this level of detail.
It absolutely is. Shows what's possible.
Okay, so let's get into it. This image shows the Elephant's Trunk Nebula, or IC 1396A. What exactly is this structure? What are we looking at?
Well, fundamentally, it's a dark, very dense cloud, like a globule of gas and dust. It sits inside a much larger region, IC 1396, which is full of ionized gas. That's up in the constellation Cepheus.
And the name Elephant's Trunk, that comes from how it looks in visible light.
Right. Exactly. You see this dark sort of winding patch, and it has this bright, curvy rim. It really does look like an elephant's trunk, especially in certain wavelengths.
Okay, that bright rim you mentioned that seems key to its appearance. What causes that?
Yeah, that's crucial. There's a very bright, very massive star nearby. Well, a multiple star system, actually. HD 206267 is just off to the east. And its light, particularly the strong ultraviolet light, is just blasting the surface of that dense cloud.
Blasting it, so it's lighting it up.
Yes, it lights it up. That's the bright rim we see, but it's also ionizing the gas, stripping electrons, and physically pushing on it, compressing it.
Wow, okay, so the light isn't just illuminating, it's actively sculpting the nebula.
Precisely. Sculpting and compressing. The dense gas of the trunk can sort of shield itself from being completely eroded away, unlike the surrounding lower density gas in IC 1396.
That's fascinating. So this interaction, this pressure, does that tie into why it's important? Our source mentions star formation.
Absolutely. That's the really exciting part. This region, especially the rim, is under incredible compression. And that compression is what triggers new stars to form. It squeezes the gas and dust together until gravity can take over.
So are we actually seeing new stars being born in this image or in the region?
We are, though maybe not directly in this visible light image. Infrared observations back in 2003 were key. They found several really young stars, protostars less than maybe 100,000 years old, still forming deep inside the dusty cloud.
Wow. Babies by cosmic standards.
Definitely. And there's more. There are also a couple of slightly older stars, maybe a couple of million years old, still young. They're found in this little circular cavity kind of in the head of the elephant's trunk shape.
A cavity, so like a bubble inside the cloud.
Exactly. And the thinking is that the powerful winds blowing off those young stars cleared out that bubble.
Okay, so let me see if I've got this straight. You have the big star outside pushing in, compressing the rim.
Right. Ionizing and compressing.
And then you have these slightly older young stars inside, pushing outwards with their winds.
You got it. It's this amazing interplay of forces, the external pressure from the massive star and the internal pressure from the winds of the stars already forming inside. All this action, this compression, is what's driving the current wave of starbirth there, creating new suns.
It's incredible, a cosmic nursery shaped by both light and wind. So reflecting on our deep dive today, we've seen how this iconic shape isn't just static, it's sculpted. And it's a place where new stars are actively being created.
Exactly. And maybe think about this. The very light from that massive star, the light that creates the beautiful image we see and allows us to study it, that same light is also the driving force compressing the gas, triggering the birth of the next generation of stars within the nebula.
A cycle of creation powered by starlight itself.
Right, and knowing that this kind of dynamic process, this constant rebuilding is happening across the universe, even 2,400 light years away, well, what does that tell us? It makes you wonder how many other places like this are out there just waiting for us to point our lenses or maybe even backyard telescopes towards them.